Hello everyone! In this video I'll show you how to perform a Varimax rotation after a PCA. To start off, let's consider the dataset I used for the video of PCA, the two whiskies. You can find the link at the video, the PCA video, in the description below. Just a quick description of this dataset. This is made of 43 rows and 14 columns. The first column is the sample name, the second is the category variable telling the type of whiskey, A or B, and each sample of whiskey is described by 12 variables. Chemically speaking, 12 chemical components from a ZC analysis. Now, let's import this dataset through the copy and paste option. Let's open cat, data handling, load, copy and paste. Let's give it a name TW as the previous one. Let's right click, paste. Row labels, header row. OK. Dataset imported. At first, let's perform the PCA. To do this, we go to the PCA menu, Model Computation, PCA. This time I go a little bit faster. TW, let's define the matrix to and 10 components, auto scaling, OK. PCA done. And now let's look at the loading plot and the score plot. Plot, loading, scatter, column names. Let's use the arrows as well. OK. And the scores. Loading plot and score plot. Let's just focus on the loading plot. We have these two groups of variables correlated with each other, being alcohols and esters. These two groups have a diagonal direction, as you can see. In these cases, we cannot assign a unique chemical meaning, a specific chemical meaning to each component, because it doesn't match the right component axis. Therefore, we could consider a Varimax rotation. Before explaining it from a conceptual point of view, let's do it straight away. So let's minimize these two plots. To do the Varimax rotation is quite simple. We go to the same menu, PCA, Model Computation, and just below PCA we go to Varimax. The dialog box is similar. We need to define the matrix on which we want to compute the PCA. TW, all rows, columns from the second to the last one, number of components 10, and let's do the auto scaling. After, we will be asked on how many components we want to perform the rotation, and the script plot appears. So in this case we go for 2 components. Here the message on the console is quite different. We can see Varimax, variance explained by 2 components, 64.79%. And then explained variance by each component, here called factor 1 and factor 2. It must be noted that the sum of the variance explained by the factors is equal to the sum of the variance of the significant components on which the rotation was made. Now let's have a look at the loading and score plots. PCA, plots, loadings, scatter, column names and arrow, and let's do to have a clear picture also the score plot. This is the whole picture after a Varimax rotation. But now let's look again at the loading plots. After Varimax rotation and before Varimax rotation. From a conceptual point of view, this orthogonal rotation makes sure that each variable has maximum loading just for one factor and minimum for the others. Thus, the principal components are called factors. Indeed, this is also known as factor analysis. This is useful to improve the interpretability of each factor and then assign a specific chemical meaning such that factor 1 explains alcohols and factor 2 explain esters. Before the Varimax rotation, this was impossible because of these directions. Now let's take the scope plots back. Here we are. Likewise, the scores rotate orthogonally, and this is the result. Indeed, in this case, the interpretation after the rotation becomes clearer, having each component explaining a specific chemical meaning. Factor 1 explains the alcohol, while factor 2 explains the esters, being the one responsible for the main difference between the two classes. Furthermore, being an orthogonal rotation, there is no distortion of the space, and you can see just by comparing the two plots. It is just an orthogonal rotation without any distortion. This is the end of the video. I hope you enjoyed it. Don't forget to like it, and please don't forget to subscribe.